This video will show you how to solve a rational inequality. First off, a rational equation is an equation that has a fraction expression equal to something. So a rational inequality is going to have some sort of fractional expression greater than or less than a value over here. If you have already done the quadratic inequalities or the polynomial inequalities, this process is very similar. But there's some things that are a little different in the very beginning. First off, we have to have all of the terms on the left side of the inequality and have 0 over on the right side. You must then write the left side as a single quotient, which it is in this case. This is a single quotient, one fraction. Then we set the numerator equal to 0 and solve. That'll be very simple. Set the denominator equal to 0 and solve. That's another very simple step. And then this is where it is similar to the polynomial inequalities. We need to plot these points on a number line, and then we do the test points to determine which intervals need to be shaded. Because we're dealing with an inequality, you know there's going to be some shading involved. And once you get that done, you're going to write your solution in interval notation. So let's take a look at this problem right here. Once we get through everything, I will show you why we do what we do. Set the numerator equal to 0, set the denominator equal to 0. Very simple to solve. We get x equals -5, x equals 2. We're going to put those on a number line in chart form, just like we did with the polynomial inequalities. Here's the x plus 5, which is the top. Here's the x minus 2, which is the bottom. And then here's the quotient of the two. So let's do some test points. Pick something to the left of -5, like -6. -6 plus 5 is a -1. Remember, we don't care what the number is. All we care about is what the sign is going to be. A -6 minus 2 is a -8. Then the quotient of these two just really means to look at these two signs. A negative divided by a negative is a positive. That's going to be the sign that's important to us. Pick a number in this region. 0 is a good number. 0 plus 5 is a positive. 0 minus 2 is a negative. If we do the quotient of these two signs, a positive divided by a negative is a negative. Pick something in this region, which means something to the right of 2, so I'll pick 3. 3 plus 5 is a positive value. 3 minus 2 is a positive value, and a positive divided by a positive is a positive. Because this says greater than, the values that are greater than 0 are the positive values. So we are only looking at the bottom row. And where the bottom row shows a plus, that's the region that gets shaded. So since this is a plus, that was referring to this region. This is a plus here, that's referring to this region. What's left is to decide what kind of symbols to have on this. Because this is plain old greater, they will be the curved parentheses. From there, we can go to our interval notation. So this interval here is from -infinity to -5, together with or 2 out to +infinity. Now take a look at this graph. This will hopefully show you why we do what we do. Here's the curve already graphed for you, and you can see that the green there, that is where our function is greater than 0. That's where the function is above the x-axis. But you might say, wait a minute, why is it 5 and why is it 2? Where does that come from? Well, this -5 here is related to the fact that we have an x-intercept at -5. And what does x-intercept have to do with anything? Well, if a curve is going to cross the x-axis, it had to have come from down here and then gone above the axis, or vice versa. But in this case, it started low, went through the axis, and then considered high, namely above the y-axis. So that explains why we have -5. Why is it greater than 2? Well, because x minus 2 would have given us our vertical asymptote. So that 2 is what kind of chopped the graph into this side and that side. So anything greater than 2 is staying up here. You might say, wait a minute, is there a possibility it crosses the horizontal asymptote? Remember, you can check to see if a curve crosses the horizontal asymptote by taking the function and setting it equal to the horizontal asymptote and solving. Well, this doesn't solve out to give you a point where it crosses the horizontal asymptote. So that's how you know this stays entirely positive. So that's why we do what we do. That's why we set the numerator equal to 0, and that's why we set the denominator equal to 0 and solve. Same setup. I typed it all in here for you again. We are going to set the numerator and denominator each equal to 0. Solve them. We get -5 and -2. We do our chart, and then we have to do the test points. So something in this region would be any number that's to the left of -5. I choose -6. -6 plus 5 is a negative value. Negative 6 plus 2 is a negative value. A negative divided by a negative is a positive. Pick something in this region, something between negative 5 and negative 2. How about negative 4? Negative 4 plus 5 is a positive 1, so that's positive. Negative 4 plus 2 is a negative. A positive divided by a negative is a negative. Something to the right of negative 2 would be something like 0. Put 0 in here. 0 plus 5 is a positive. 0 plus 2 is a positive. A positive divided by a positive is a positive. This original problem was less than 0. The values on a number line that are less than 0 are the negative values. So look at your bottom row, and where you see a negative indicates that's the region that needs to be shaded. So we're going to shade between here and here. What kind of symbols would we use? Well, since this is plain old less, we're going to get the curved parenthesis on that. Interval notation. This is simple, from negative 5 to negative 2, both with the curved parenthesis because that's what we have on the graph. New problem, set the numerator and denominator each equal to 0 and solve those. Just a little comment here, there's two ways to solve this. This one's very simple. You can do this in your head. Subtract x, or subtract 2 from both sides, you get x equals negative 2. But if you just add 3 to both sides here, you have negative x equals positive 3. You're not done yet. You could change this to positive x, which makes this negative 3. Or you could add x to both sides, which is still going to give you x equals negative 3. That's what I did on this screen here. I added x to both sides to give me that. Either way, those are the 2 points that are going to go on my number line. And here are the values going down the side. I've got to pick some test values. To the left of negative 3 would be negative 4. Now, if I put a negative in for that x, we're looking at negative of negative 4 minus 3. Negative of negative 4 makes positive. 4 minus 3 is a positive value. Put negative 4 in here. Negative 4 plus 2 is a negative. A positive divided by a negative is a negative. I need to pick something between negative 2 and negative 3, so I'm going to have to pick a decimal. So negative 2.5 right here, you're looking at negative of negative 2.5. Write it out if you have to. The two negatives in a row make a positive, so this is 2.5 minus 3, which is going to make a negative. Put negative 2.5 right here, you're looking at negative 2.5 plus 2, which is a negative. A negative divided by a negative is a positive. Something to the right over here, I'll choose 0. 0 minus 3 is a negative. 0 plus 2 is a positive. A negative divided by a positive is a negative. We are looking at less than, which means we're dealing with the negative signs. So we're looking here, and we're looking here. Now here's something you need to be very careful of. If we put a square bracket right here, that would indicate that negative 2 was a solution for us. But if you put negative 2 right here, you're going to have negative 2 plus 2, which is 0 in the denominator, which is not possible. Even though this is less than or equal to, which would ordinarily make us use a square bracket, the denominator value will always get the curved parenthesis. Denominator value always gets a curved parenthesis. Does that affect this any? No, because this is less than or equal to, I do use the square bracket on that. To do the interval notation on that, this is negative infinity up to negative 3 with the square bracket. The other side is negative 2 with the curved parenthesis out to infinity. So this is important. The denominator solution always gets a parenthesis, not the square bracket. Now that only matters if the original inequality was less than or equal to or greater than or equal to. The first couple we did were plain old less or plain old greater, which were automatically going to get the curved parentheses. Another one, set the numerator and denominator each equal to 0. This requires a little bit of work. Subtract 5 from both sides and then divide by 3. Subtract 6 from both sides and divide by negative 2x. And these are the solutions we get. Negative 5/3, positive 3. Put them on your number line. Choose some values over here. Negative 5/3 is negative 1 2/3. So I could choose something as small as negative 2. Plug that in here and this will be a negative value. And if you don't know that off the top of your head, you need to write out to the side 3 times negative 2 plus 5 and do your arithmetic. 3 times negative 2 is negative 6 plus 5 is a negative 1. I don't care about the 1, but the negative is important. Put negative 2 in here. This is 6 minus 2 times negative 2. A negative times a negative is a positive. So this is 6 plus 4, which is a positive. A negative divided by a positive is a negative. If you can do this substitution in your head and get the right answer, fine. If not, write this down. Choose something in this region, which 0 is nice. Put 0 in here gives me a positive. Put 0 right here will give me a positive. A positive divided by a positive is a positive. Choose something to the right of 3, like 4. This will be a positive. This is 6 minus 2 times 4, which is really 6 minus 8, which is a negative. A positive divided by a negative is a negative. This is greater than or equal to 0, so we're interested in where we see the positive. So we know this region gets shaded. Like the last one, because this is greater than or equal to, you might think that both of these get the square brackets, but no. The one that came from the denominator will automatically get a curved parenthesis. So this is curved, and that's square. That doesn't look like a good curve, but you'll see it on the next one looking a little better. There's the curve. Here's the interval notation from -5/3 with the square bracket out to 3. The denominator solution always gets the curved parenthesis, not the square parenthesis.